There are many different kinds of probability that are covered within math methods. This video in particular is going to focus on how we solve discrete probability questions. There are a few different topics within discrete probability. The ones we're going to focus on is how to use probability distribution tables and all the questions that are associated with those. For those that don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defense company and I left that to start a career in tutoring. I now make these videos for VCE students so that they do the best they can in math methods. With that out of the way, let's get into it. Discrete probability is all about quantities that can only occur in specific values. The typical example is rolling a dice. You're only ever going to get the numbers between 1 and 6. You'll never, for instance, roll a 0.5 on a dice. This is a discrete probability type of question. This is in contrast to continuous probability, which has no upper limit to the accuracy of each of its specific values. The typical examples here cover things like length. For example, if I were to measure a rope, I could say that it's approximately 1 meter. But if I measure it a little bit more accurately, I could say it's 1.02 meters. But if I then go back again and measure it even more accurately, I might find that it's 1.025779, etc., etc. But continuous probability is a topic for another time. This video is just going to focus on discrete. Discrete probability is often represented by using probability distribution tables. To start these out, we need to first figure out, well, what is the discrete quantity that we're actually tracking? We usually define this as capital X. For example, if the table is supposed to be tracking the likelihood of rolling a 1 on a die, then capital X will be the variable that tracks the number of 1s that are rolled on the die. The top row is denoted by little x, and that represents the possible numbers that capital X could be. For example, if we're rolling the die 3 times, then our possible outcomes could be anywhere between rolling no 1s on the die, capital X equals 0, and rolling 3 1s on the die, capital X equals 3. The second row is then the probability of any of those outcomes occurring. We're going to look at how to calculate that in a minute, but for now there's a few guidelines that are worth pointing out. First is that all the probabilities in the table need to be between 0 and 1. This is true for any type of probability. Second is that the sum of all the probabilities in the table need to add up to 1. This is because a probability distribution table covers all the possible outcomes of that scenario. And so every possible probability has to add up to 1 for a given scenario. And lastly is that complement probabilities are often used to either simplify things to make things a little bit easier to do, or just straight up will be the only way that you can solve some types of questions. We're going to look at a few examples like that. So how do we actually solve these probabilities? Well, the true answer is that it depends on the question, but in most cases an approach like this will work. In this case, we have a jar containing 4 white balls and 6 black balls, and we are selecting 3 of them with replacement. The term with replacement just means that every time we pick a ball out of the jar, we put it back. So basically we're just selecting 1 ball from the jar, noting its color, putting it back, and then repeating that 3 times. Now that we know that, we have to set up our probability distribution table. But before we can do that, we have to figure out what variable is it that we're actually tracking. And in this case, it's the number of white balls that are drawn from the jar. Now that we know what we're tracking, let's figure out the possible outcomes of the scenario. And in this case, you're going to draw anywhere between 0 and 3 white balls. Now that we know that, it's time to find the probabilities. Let's start with x equals 0. This means that of the 3 attempts, we only draw black balls. To begin with, we need to figure out what the baseline probabilities are of getting a black ball versus a white ball. Now, there's 6 black balls out of a total of 10, so we got a probability of 6 out of 10. And there's 4 white balls out of a total of 10, hence the probability of that is also going to be 4 out of 10. If we know we're just drawing 3 black balls in a row for x equals 0, then all we're going to do is take that probability of drawing a black and then multiply it by itself 3 times. To fill out the other slots on the table, we have to do a little bit more thinking. For example, if we're going to look at x equals 1, that's getting 1 white ball. But that can occur in 3 different ways. It either occurs in the first slot, the second slot, or the third slot. The probability of getting a white ball is 4 out of 10. So all we're going to do is just sneak that 4 out of 10 into one of the slots of those combinations. And technically you can do that for all 3 combinations, but when you do that, you're going to realize that you're going to get the exact same numbers that are multiplied together, just in different orders. So if you want to speed things up a little bit, you can just take that first probability and multiply it by 3. You're going to get the same result. X equals 2 is only mildly different. The only difference here is that instead of having 2 6 out of 10s and 1 4 out of 10, you're going to have two 4 out of 10s and one 6 out of 10. And again, those can be arranged in any order. If you count out the number of possible combinations that occurs in, it's just going to be the same thing as multiplying that first one by 3. And then finally, we have x equals 3, which is just all white balls. So 4 out of 10 by 4 out of 10 by 4 out of 10. And as a final check, if you like, you can add all those probabilities up in the table just to make sure that they still add up to 1. This will make sure you haven't made any minor mistakes as you're filling these out. Alright, well, what if I want to find the probability over an interval? Well, the good news is we don't do a whole lot more different. All we're going to do is just add up all the probabilities that belong to that interval. So for example, if I want to find the probability that x is greater than 1, I'm just going to add x equals 2 to x equals 3. Notice that I've excluded x equals 1 from that. This is because the inequality was not an inclusive inequality. It was greater than, not greater than or equal to. I mentioned earlier that complement probabilities can be helpful for these. Let's look at another scenario where we're trying to find the probability that x is greater than or equal to 1. The table is mostly empty. The only thing we do know is probability of x equals 0. In other circumstances, you might be able to just add x equals 1 to x equals 2 to x equals 3, but that will take a fair bit more time. Instead, we can find the complement probability, because we know that everything in the table needs to add up to 1. So instead of finding probability of 1 plus probability of 2 plus probability of 3, you can instead do 1 minus everything that is outside of the interval, which in this case is just going to be 1 minus x equals 0. In some questions, this is literally the only technique that you can use to solve the question. But that's not necessarily true in other areas of probability, though this idea does come up in pretty much every area of probability, so it's worth remembering this one. In some cases, your probability table is going to contain variables, and you're going to be asked to figure out what are the possible values of those variables. In the vast majority of these cases, you're just going to take every entry in that table and add it all up together and let it equal 1. This is because it doesn't matter what probability table you have, every entry in that table needs to sum together to give 1. When you do that, you're going to get a situation where you have an equation with only one variable in it. So all you have to do is solve for that variable. In this case, we have a quadratic, so I'm going to use the quadratic formula to solve for the possible values of p. And that's going to give us p equals a fifth and p equals -1. Now, let's remember from earlier, all probabilities need to be between 0 and 1. That doesn't necessarily mean that p has to be between 0 and 1 though. Although in this circumstance, if you compare it to all those probabilities, you'll notice that if we choose p equals -1 as a solution, we're going to still get a number that is either too negative or greater than 1, which we can't allow. So the only valid solution is going to be p equals a fifth. Conditional probability questions apply to all different types of probability that you're going to look at throughout math methods. Here's how it works for discrete. Well, to start with, every time you do a conditional probability question, you start by writing out the conditional probability equation. The main thing we want to do here is to simplify the intersection at the top of the fraction, and we can do this visually using a number line. We're just going to plot each inequality on that number line and then look for the overlap. And in this case, it's going to come out to be between 1 and 2. Remember, a less than sign means that you exclude the value. So the probability x less than 3 actually means from x equals 0 to x equals 2. So now we're just going to solve the numerator and denominator using the techniques that we mentioned earlier. The numerator is going to be given by adding x equals 1 to x equals 2, and the denominator we have two choices with. You can either add x equals 0 to x equals 1 to x equals 2, or you can just do 1 minus x equals 3. This fraction is just going to simplify down to 10 over 13. This would have been a CAS question, so don't worry too much about how you would do that by hand. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.